Welcome back again to another video here at Math Rocks with Mr. Cox. In the previous video, we were discussing if you had polynomial functions like a cubic function here that, generally we're going to have three different zeros or roots because the graph crosses the x-axis three different times, and how to actually come up with the equation for that cubic function. Well, what if you had a cubic function like this, but it only crosses once? Well, what happens to those roots? I know back here we had three, now we only have one. Well, what happened to the other two roots? Well, the short answer is they become imaginary or complex. And if you want to see how that plays out, stick around. Let's get it on. So taking a look at these two function graphs here, we have over here a cubic function that has one real root. So I'm going to go ahead and write that over here. So we have one real root. But because it's a cubic, we ought to have three roots altogether. So what happened to the other two? Over here, we have a quartic function. So that means we have four roots. And you'll notice here it crosses the x-axis twice. So once again, we have two real roots here. And we're missing two roots. And what's interesting is every time we have these missing roots, they're going to be what's called complex numbers. And a complex number is nothing more than a real number plus or minus a imaginary number. So for instance, one of them might be, for instance, 0 plus 6i. That would be considered a complex root. And the other thing is if that were our root that's complex, the other one is going to be what's called the conjugate. It'll look exactly the same, except it'll have a minus in between the real and the imaginary number. It could be something like this, 2 minus 4i. And then therefore the other one would be 2 plus 4i. So just understand, every time that we have non-real roots, aka complex roots, they're always going to come in pairs, and they're called conjugates. All right, so now that we've got that out of the way here, I have an equation here, and it's already in factored form. So we have x minus 2 as a factor, another one is x squared plus 16, and then x squared plus 6x plus 3. And the directions are to go ahead and determine what the roots are and describe them. So let's do the easy one first over here. If we set x minus 2 equal to 0, that's how we find our roots here. Obviously, x would be 2, and that is what we call a real root. So we have a real root here. If we were to take the second one and now set it equal to 0, we would get x squared plus 16 equals 0. And then when we subtract 16 on both sides, we're going to get x squared equals negative 16. And now when we go ahead and square root both sides, we're going to get x equals, well, what is the square root of negative 16? Well, that is an imaginary number. It'll be plus or minus 4, just like if it were 16, but it has an I here. Or other word, if you want to write it more looking like a complex number, you could write 0 plus or minus 4i. So once again, we have a pair here, what's called a conjugate. One is 0 plus 4i, and the other one is 0 minus 4i. So these are what we call two complex roots. And then finally, we have over here, if we set this one equal to 0, I'm going to go ahead and do that. So this one's going to take a little bit more time here because we have an x squared, an x, and a number. So we're going to have to use the quadratic formula here. So I'm going to go ahead and do that. So I have a equals 1, I have b equals 6, and I have c equals 3. So therefore, when we do the quadratic formula, x is going to be the opposite of b, so that'll be negative 6, plus or minus the square root of b squared. Well, 6 squared is 36, and then it's always minus 4 times whatever a is, so that's 1, times whatever c is, which is 3. And then it's all over twice a, so 2 times 1. So I'm going to go ahead and simplify that a little further. So when I simplify the inside, if I do this here, 4 times 1 times 3 is 12, 36 minus 12 is 24. And then obviously 2 times 1 is just 2. All right, and then the last thing we're going to do here is we're going to go ahead and we're going to simplify this. So 24 is 4 times 6. So I know it's 3 times 8 and 12 times 2, but the reason why I chose 4 times 6 is the square root of 4 is 2. So I can rewrite this as negative 6 plus or minus 2, keep the square root 6 inside there. And then if we look at all the numbers that are not inside the square root, they're all divisible by 2. So when I do that, that's a 1, that's a 1, and that's a 3. So our final answer over here is going to be negative 3 plus or minus the square root of 6. Now, this is not a complex number because that square root of 6 is real. This is actually called a real, and then because we can't simplify this as an actual number, the square root of 6 is a decimal number that repeats infinitely. It's called a real irrational. So going back to the first one, we had real roots, but these is what we call a rational root because rational just means it can be written as a fraction. So 2 can be written as a fraction 2 over 1. So we have one real rational root, we have 2 complex roots, and then we also have 2 real irrational roots. Wow. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. We're going to go ahead now and turn this around, and actually we know what the roots are, and now we're actually going to write the equation in what's called standard form. So let's go ahead and do that. So in the last video, we talked about all you have to do is if the root is 5, that means one of our factors is going to be x minus 5. Likewise over here, if we're going to have 3 plus I know that's a complex number, but it's going to work the same. So we're going to say x minus 3 plus I, and that's going to be in its own little mini parentheses here. And then the last one will be x minus, and this is going to be 3 minus I. All right, well, this is not in standard form. This is what we call factored form. We can simplify it a little further if you like. We can say x minus 5 still, and then we can turn this into x minus 3 minus I if we distribute the negative here. And if we distribute the negative in this one, we can say x minus 3, and then minus a negative I would be a plus I. So at least now it's a little simpler here, but we're still not in standard form. So to do that, we're going to have to go ahead and do some multiplying here. So let's go ahead and multiply these 2 ugly factors here together. So I'm going to go ahead now and I am going to make a 3 by 3 box here as best I can. So hopefully you can see how this all works here. I'm going to write x minus 3 minus I along the top here. And I'm going to make my 3 boxes this direction here, and I'm going to write x minus 3 plus I. And I realize this looks super ugly right now, but you'll see a lot of things end up canceling out. So x times x is simply x squared. X times negative 3 is negative 3x. And x times negative I is negative ix. And once again, I know this looks ugly, but stick with me here. Negative 3 times x is going to be negative 3x. Negative 3 times negative 3 is a positive 9. And negative 3 times negative I is a 3i. And we're going to continue on here. I times x is a positive ix. I times negative 3 is negative 3i. And then finally, I times negative I would be negative I squared. Alrighty, so as promised, a lot of things will cancel out here. So with the 3i and the negative 3i cancel out, negative ix and positive ix cancel each other out. I squared is equal to negative 1. So this is really equivalent to negative 1, which we know is equal to positive 1. So when we're done here, I know there's a lot going on here, but we're going to have x squared, negative 6x, and then 9 plus 1 is 10. So when we multiply these two together, what we really get here is we still have the x minus 5 out here, and now we have x squared minus 6x plus 10. So that's a lot more comforting and something we're used to seeing here. And then finally, we're going to need to go ahead and multiply all of this out. So I'm going to go ahead and now make another box. So here's my next box here. And along the side, I'm going to go ahead and I'm going to write x minus 5. And along the bottom, I'm going to write x squared minus 6x plus 10. And then to do all the math here, let's go ahead. X times x squared is x to the third. X squared times negative 5 is negative 5x squared. Negative 6x times x would be negative 6x squared. Negative 5 times that would be 30x. And let's see, 10 times x is 10x. And then finally, 10 times negative 5 is negative 50. And then some of these things are going to combine together. So here's our final answer right over here. So our standard form is going to be f of x equals, we have an x to the third. Altogether, we have negative 5 and another negative 6. We have negative 11x squared. 30 and 10 is 40, so we have 40 x's. And then finally, we have a negative 50. Wow. Like I said, that's a lot of work there, but it can be done. And we're going to use the same principles we used at the very beginning here, which was if we know the roots, define a factor, we always say x minus the root. So I hope you got a lot out of this video and hope to see you again soon. Thanks for watching.